Hello there. Today I'll be showcasing a program called MStower. MStower is a Windows program that allows designers and authorities to analyze lattice structures. It allows you to design transmission towers, communication towers, guy masts, and poles. So let's get started. Open up MStower. And I'll show you the structure we'll be trying to build. So here is a transmission tower, and it has 4 faces. This is looking at it in elevation. So what we have is 11 panels, being panel number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So each of these panels has 4 faces, and each face has a configuration, and we'll be programming these into our model. So we go to MStower, new file, give it a name, demo1. So MStower takes 2 input files and optionally a 3rd input file for user-defined panels, but we won't be talking about that today. So it's the geometry of the tower will be defined in a file called tower data file, and the loadings, configurations, and combinations will be defined in a tower loading file here. So let's go to tower data file. So normally you would open an example and modify its existing tower data file. Or if you want to start from scratch, what it does is this builds you a skeleton. So make tower data file, demo1, number of faces 4, number of panels we have 11, but for the sake of this wizard we only do 1. Hit OK, hit OK. And this generates a bare minimum skeleton for the tower data file. What I've done previously is I've generated a tower data file that works, which I'll be copy and pasting into here. So as I'm copy and pasting, I'll be explaining what's going on. So here, title 1, title 2, these are the keywords to put your titles in here. Units 1, profile, it's a keyword. Faces is a keyword, it's saying how many faces are there to your structure. We've previously defined that to be 4. W base is the dimension of the base, which in our case here is 6.781 meters. And without further parameter, this is saying it's a square base structure. RL base is a reduced level of the base of the structure, which is a 0, 0. Now, this is one panel block. Remember we previously said there's 11 panels to our structure. So there'll be 11 number of these blocks with different panel number, height, and width of this panel, along with different configurations that goes in here. So I'll copy and paste across, and I'll explain to you what I mean by that. So here I copied across 11 panel definitions. So this is saying it's panel 1. The height of this panel is 1.219 meters. Its width is 0 because at the apex of our structure it meets the width of that is 0. Its face is a keyword, and it's an X type panel. What does it mean, X type panel? We go into help, MStower help topics, we go to standard panels, X face panel. So this is the panel we're after. So it's saying at the very top it looks like this. That's what that means. And then that's the name of the member, leg, BR1 and H1. Leg, BR1 and H1. The number following the member denotation is saying the section number that belongs to this area. So it's saying for leg, assign section number 1 to these members, and assign section number 0 to BR1 and section number 0 to H1. Section number 0 is a special type of section. It's saying there's nothing there. So it's saying because X face panel has a cross brace across here, but at our very apex that disappears and it meets at a point. So it's giving it 0 cross section. And so on and so forth. There's various definitions for different faces, and plan the cross arms as well. So from here to here we define a geometry, and below here is a section block which we define the type of section that exists in this project. So let me copy and paste across. So this is saying the library that I should look for is section data is the Australian section library. That's the section number. Section number 1 is a 40 by 40 by 6 equal angle. So we're assigning that to this area here. So there you go. Now all we gotta do now is get out of here, hit save, ask the program asks you to rebuild tower, hit yes. And there you have it. This is our model with the correct sections assigned. Now the second step is we need to input the loading configurations. So we go to tower, load tower, make tower loading file. So in here we select the right code. Hit OK. Add a couple more win angles. Hit OK. Hit OK. And what this does is it generates the tower loading file. And you can go in here to do some cleanups. I notice there's a typo in here, so let me clean this up. Now we go to process tower loading file to see if there's any errors. Appears okay. So what we do now is build low analyze. Hit okay. Now that the structure's been analyzed. So after the analysis, we can see some results. So if we go display shape, so under load combinations, this is the display shape. Now to get some sense of what's going on, we can just select one to view. So under that particular load combination, this is the display shape. We can see its bending moments as such, its shear forces, its torque, and we can also animate what this will look like. now we've previously assigned sections to the members. Now let's check whether these are satisfactory according to Australian standards. So let's hit member check, tower mass AS3995. Hit OK. Hit OK. Combinations to check against. Hit OK. So there you have it, done as check. So here I'm going to check the design ratio. Select this button. And what you see in red, which I'll load up the legend here. The legend here says we're over capacity in the red sections. So here you can clearly see this region is overloaded, and we can go back to our edit tower data file and modify the necessary cross sections and rerun the analysis. So outputs we can get from this is we can print reports, detail, report. So there you have it. I hope you found this helpful and see how powerful MStower is. Thanks for listening. Bye.